Hello everyone, welcome back to the last part of this chapter, working with normally distributed variables, where we will utilize the technical knowledge that we learned from all the previous section in this chapter to solve some of the real data application problems where variables are normally distributed. For normally distributed variables, there are some nice properties to them, one of which is the empirical rule that you may have learned earlier in the semester. So is a short review of it. For any variables whose distribution is bell-shaped, particularly normally distributed variable, the following three properties hold. Property 1. Approximately 68% of all possible observations lie within one standard deviation away from the mean, namely mu minus sigma and mu plus sigma, so just one standard deviation away from the mean in either the negative direction, that is why we subtract, or the positive direction, that is why we plus. Property 2. Approximately 95% of all possible observations lie within two standard deviations away from the mean. In the negative direction, that is why mu minus 2 sigma, and in the positive direction, that is why mu plus 2 sigma. And of course, as you know, mu stands for population mean and sigma stands for population standard deviation. Property 3. Approximately 99.7% of all possible observations lie within 3 standard deviation away from the mean, mu minus 3 sigma and mu plus 3 sigma. There's a typo right there, should be property 3. The empirical rule, I include a nice visual graph here for you, the bell shape. So because this applies for any bell-shaped distribution, but particularly normally distributed variable, that is why we have a nice bell shape here, center at the mean, as you know. If you shift that one standard deviation away, mu minus sigma or mu plus sigma, you would capture about approximately 68% of all possible observations. If you shift two standard deviation away, namely mu minus 2 sigma, mu plus 2 sigma, you would capture about 95% of all possible observations. Three standard deviation away, mu minus 3 sigma, mu plus 3 sigma, you would have 99.7% approximately of all possible standard deviation here. So this is the meaning of the properties, and I think this picture kind of help see how the properties kind of go. Let's do one example to illustrate this rule. This example is about rainfall in Roanoke, Virginia. So this is a county, and I hope I say the name correctly. So the average annual rainfall recorded in the nearest hundredth of a centimeter in Roanoke, Virginia is 12.45 centimeter. Assume a normal distribution with a standard deviation of 2.13 centimeter. Fill in the blanks. A. Approximately 68% of all average annual rainfall recorded in Roanoke, Virginia will be blank and blank between blank and blank centimeters. B. Approximately 95% of all average annual rainfall recorded in Roanoke, Virginia will be between blank and blank centimeter. C. Approximately 99.7% of all average annual rainfall recorded in Roanoke, Virginia will be between blank and blank centimeter. So how do we go about doing this problem and fill in the blank? So the very first big hint is that you see they say assuming a normal distribution, and then you see that approximately you see the three familiar numbers 68%, 95%, 99.7%. So yes, you're right. You are thinking about using the empirical rule for this problem where it exactly applies here. So let's do part by part first. Part A, approximately 68% of all average annual rainfall recorded in Roanoke will be between blank and blank centimeter. So because it's 68%, we know that it should be the bound, the lower bound and the upper bound should be only one standard deviation away from the mean, with the lower bound will be mu minus sigma, as we show on the previous page of the property and also you saw on the graph. So you have the mean and the standard deviation given by the problem. Subtracting the two, you get 10.32 centimeter. That is the lower bound. The upper bound is just one tiny difference. That is now the minus sign becoming the plus sign. Adding the two, you get 14.58. So your answer would be approximately 68% of all average annual rainfall recorded in Roanoke, Virginia, will be between 10.32 centimeter and 14.58 centimeter. Very good. So let's move on to part B. Approximately 95% of all average annual rainfall recorded in Roanoke, Virginia will be between blank and blank centimeter. Yes, I think you got it. So since it's 95% this time, you know that the bound should be two standard deviations away from the mean, with the lower bound being mu minus 2 sigma and the upper bound being mu plus 2 sigma. You have the value for mu, you have the value for sigma, we just substitute in. So the first one, taking the mean, subtract 2 times the standard deviation, we get 8.19. And then adding the two quantity instead of subtracting them, you should get 16.71. So you see that now this interval widened compared to part A, with the answer being approximately 95% of all average annual rainfall recorded in Roanoke, Virginia will be between 8.19 centimeter and 16.71 centimeter. Last part, approximately 99.7% of all average annual rainfall recorded in Roanoke, Virginia will be between blank and blank. So here 99.7%, we know that the bound should be 3 standard deviation away from the mean in both direction, negative and positive. So very similar to the last two parts that we did. Now we just substituted the value mu minus 3 sigma and mu plus 3 sigma. You have the values for those quantities. Just substitute them using your calculator and you should get 6.06 and 18.84 centimeter. That should be your answer right there. Okay, so you see that this interval even wider compared to part B and part C because when you increase the percentage of all possible observation that you want to capture, you would widen the interval out. So that is the example to illustrate the empirical rule. So when you're working with normally distributed variables, you boil down to two main problems of interest. The first problem is to determine a percentage or a probability for a normally distributed variable. Problem 2 will be determine the observation corresponding to a specified percentage of probability for a normally distributed variable. As you can see, I include two main formulas here for you to use, each one associated with one problem that I discussed. For problem 1, determine the percentage of probability for a normally distributed variable. You can see that the z-score formula is mainly used here, and you have seen this one before. Z equal to x minus mu over sigma. So what is this problem? This is similar to section before or the previous video you watched. That is when you have a z-score, you calculate and you have the z-score, you try to use that z-score to go to the standard normal distribution table to find a percentage or the area that gives you the probability of interest. That is why I include this formula here because most of the time you have to find z-score first before you can find the area. Problem 2, determine the observation corresponding to the percentage for a normally distributed variable. You have the formula x equal to mu plus z times sigma. This looks a little bit new, but it's not too new. It's just the z-score formula rearranged and solved for x. With a little algebra, you can see But if you are not very interested in the algebra, there you go. You have the form and you can just use it. This corresponds to what you had before. You have the area. Now you try to go back and find the z-score, the reverse method that we also discussed in the previous video. And also, you go one more step further from the z-score. You convert it back to x. And what is x? That is the original variable of interest the problem usually gives you. Okay, to illustrate myself a little bit more clearer, we'll do two examples, one for each of these problems, so you can see how the procedure goes and you can see how to apply the formulas. So let's look at the first example involving battery life. A certain type of flashlight battery lasts on average 5 years with a standard deviation of 0.75 year. Assuming that the flashlight battery lives are normally distributed, find the probability that a given flashlight battery will last more than 6 years. So it's very important that you can identify this is the problem, the example of the first problem. Determine a percentage or probability of a normally distributed variable. How do you see that? First, look at the line where they say assuming the battery lives are normally distributed. So you know this is the problem with a normally distributed variable. Second, they say find the probability. So you know from these two, it match the definition of the very first problem. So here, you know that you have to use the first formula that I presented to you. So first you find the z-score, then you can use that z-score to go to the table to find your area. That area gives you the probability. Not too bad, right? So here, look at all the numbers they give you and try to make sense of them a little bit. They say that the battery lasts on average 5 years. Average here is the mean, so you know that 5 years is the mean, or mu equal to 5. Standard deviation of 0.75 years, so you know that that is sigma. And they ask you to find the probability a flashlight lasts more than 6 years, so that is your interested x value. So here I try to draw a graph out. As I talked to you before, I would really suggest sketching a normal curve because it's beneficial for you to visualize the problem. So here the mean or the center will be 5. We discussed that. And then x equal to 6 is what you're interested in finding. I shade a red area to the right of x equal to 6 because we're interested in finding the probability that the battery life lasts more than 6 years. So here, the first line I have x values. I will try to convert that to z-score number 6 using the formula I discussed before. Z equal to x minus mu over sigma. X is 6, mu is 5, sigma is 0.75. So my z-score is 1.33. So here you see right underneath the x, I have the values for z. So now 5 becomes 0 because the standard deviation, the standard normal curve has a mean of 0. Or you can just substitute in the z that formula 5 minus 5 over 0.75 is 0. And now 6 convert to 1.33. So with the z-score, go to the table, you can easily find the area. But be cautious, what the table gives you is the area to the left of 1.33, not to the right. So to find the area to the right, which we're interested in, the shaded red area, just subtract what the table gives you, 0.9082 from 1, and you get 0.0918. Okay, so the area to the right of z equal to 1.33 is 0.018. Thus, the probability that a given flashlight will last more than 6 years is 0.0918 or about 9%. So you have about 9%, a given flashlight of this particular battery will last more than 6 years, more than the mean of 5 years. Okay, so that you can see the standard normal curve and the table is quite useful and efficient in finding the desired probability. Very important when you first started out doing this type of problem that you will sketch the curve, because normally people will tend to forget and then just use the area given by the table 0.9082, so you don't get the right answer. You are close but not quite there. So to start out, I would strongly suggest sketching out the curve, and when you get used to it, maybe you don't have to do so. Okay, let's look at another example involving IQ score. IQ score stands for Intelligent Quotient Score, and usually they are obtained from the IQ test, right? So IQs are known to be normally distributed. So here, that is a keyword, normally distributed. It allows you to use all the process that we have discussed so far with a mean of 100. So what is this? That is mu, and a standard deviation of 15, that is our sigma. Okay, so that is a tiny typo right there. 92nd percentile, or usually denoted as P92, is the IQ that is higher than those of 92% of all the people who take the IQ test. Determine this P sub 92. P here stands for percentile, 92 is the 92nd percentile. So you may have seen percentile in previous chapter. We incorporate that knowledge here to solve it for a normally distributed random variable. Okay, so here I hope that you have realized that this is the example of the second problem. Determine the observations corresponding to a specified percentage for a normally distributed variable. Until now, I think you are quite good at seeing that this is a normally distributed variable, because usually the problem will tell you so. So here, how do you see that? It gives you a percentage already. That is a 92%. 92% here, that is your area of 0.92. And because it say the IQ is higher for those of 92%, 0.92 is the area to the left. To go about solving this problem, I have a little curve right here to illustrate this problem visually. So I shaded the red area to the left because you know that 0.92 will be to the left of that. So I have 100 is the mean, stay right in the middle, and P sub 92, 92nd percentile. This area, as I discussed to you, is 0.92. So this is the exactly reverse problem from what we saw. Now you have the area. What are you interested in finding? Yes, you're right. Now we're interested in finding the z-score. How do we do that? You would go to the table. You search inside the table for 0.92, and then you match out and up to see what z value they give it to you. And there you go. You would find z equal to 1.41. Okay, so it's very important that you practice enough problems from the previous video to get used to this procedure so you can solve some of these word problems. So are you done here? A little bit close, but not quite there yet. If you remember the formula I presented to you associated with the second problem, you remember that from this z-score, you have to convert it back to x using this formula. X equal to mu plus z times sigma. Mu here is 100, z is 1.41 that you just found, sigma is 15. So you substitute all of this, you will find 156. And this x value is exactly P sub 92, or the 92nd percentile. So your final answer is that the 92nd percentile for IQ score is 156, Or in other words, in more of a plain English way, that means 92% of all people taking the IQ score test will have IQs below 156, or only 8% of the people will have IQs beyond or above this level of 156. So as you can see, working with normally distributed variable is not too complex if you understand the basic and earlier procedure of using the table. So it is important that you know how to go back and forth between z-score and area. If you're given a z-score, how do you find area? If you give an area, how do you find z-score? And of course, under the standard normal curve, using the standard normal curve table, that is a very important step before you can go into solving these word problems. The second important step is to identify what problem that is. The first problem, where you have the z-score available, you need to find the probability. Or the second problem, when you given the area or the probability, you have to convert it back to z-score, then convert it back to x, the original variable of interest that they are finding. In this case, X here representing the IQ score. It can represent any type of phenomena or variable of interest that the problem can present to you. Once you are an expert at those steps, then you would have no trouble doing all the problem of this kind. I hope this has been helpful to you and see you next time.